All right, today we're going to cover the pre-start checklist for our DXM2 communicating control line of product. We're going to first start up here at the thermostat. And to start with, we need to put it into the installer configuration. So we got to depress the up and down arrow at the same time. Hold it in for approximately 5 seconds until we get our installer menu. Once we get into our installer menu, again, our first step is our thermostat configuration. We're going to select that, and we're going to choose either between single stage or multi-stage. And again, currently all our communicating product line is multi-stage, so we'll choose multi-stage. The next item will be, do we have electric backup auxiliary heat, multi-fuel in our split systems, or no auxiliary heat? So we can select what we have. We'll select electric backup for this model. And then our next option is how we want that auxiliary heat to function. Do we want it to supplement the heat pump, or do we only want it for emergency heat purposes? So we're going to choose to supplement the heat pump. The next option is programmable, non-programmable, and night setback. Again, that'll have to be a decision you make with your particular installation. I'm going to choose non-programmable. We're now finished with our thermostat configuration. We're next going to look at the system configuration. But one statement I want to make as we go into this, these units will come from the factory already set with factory default settings underneath our system configuration. But again, if you want to make adjustments to, as you can see, the first item here, airflow selection. Anytime we want to make an airflow change, we must, again, have our communicating thermostat or our service tool in order to get into this menu to make an adjustment. So let's take a look here under airflow. And again, we have our various modes of operation. And we could select, we'll just select heating first stage, and we can move it up and down within a min and max underneath that individual stage. So I'm going to go ahead and just to show you here, we'll move this up to 800 CFM for heating first stage. We'll hit the select button, which is our center button on the stat, and momentarily it'll change to our 800 CFM. So again, we could go on down the line and make adjustments if we want to go away from the factory default settings for our particular model. We'll next arrow out of the airflow selection using the left-hand arrow. And our next option here is option selection. Under option selection, there's two items that will show up. The first one is a motorized valve. Now this is not to be confused with the modulating valve option that's inside these products. This is for an external valve. We're looking for the in-switch feedback to the heat pump once that valve fully opens. So again, this is more of a commercial option, not typically utilized in a residential product. So the motorized valve under most situations should always be in the off position, which happens to be the factory default setting. So please do not turn that on if you have a modulating valve. Otherwise, your unit will be sitting there and not operate. The next thing is our compressor anti-short cycle protection time. And again, most situations I don't foresee you needing to make an adjustment there. The factory default is 5 minutes. You cannot go below 5 minutes, but you could go all the way up to 9 minutes. We'll next take a look under unit configuration. And we currently have a YF036 here. And once I select that, you'll see the heat pump family. Again, YF. Heat pump size, 036, 3-ton model. And then the blower type. Now this is important. There's some different options under here, and I'm going to go ahead and select it to show you. We want to, again, in the residential model here, we want to opt for the ECM constant airflow. If I select it and then I move through this menu, you'll see we'll have an option for PSC blower, none, no blower, PSC 2-speed, Again, that would be more of our commercial equipment. Our ECM constant airflow. So again, we want to go back to our constant airflow, select it. Again, that's the ECM motor that we have in this product. We'll next go down to loop configuration. And again, this will be from the factory set up for the item that you have within your heat pump, the flow item, whether it be a variable speed pump or a modulating valve. And again, the modulating valve comes in two different forms, either open loop or a closed loop model. The other option under this is variable speed pump in parallel. Now, why would we ever choose parallel? Again, parallel would be if I had two of these heat pumps on a common loop, meaning that each one of these heat pumps has an internal pump, or I might even have maybe an older model with an external flow center also on that common loop. And again, if I have each heat pump has its own set of pump or pumps, then I must choose variable speed pump in parallel. So I'm going to go ahead and just show you that. I'm going to select this variable speed pump in single form on its own loop. That's what we happen to have here. But I'm going to show you the parallel option. So again, we have other. That would be configured for nothing. And if you accidentally choose that, your pump or your valve will not operate. So we would not want to do that. Or variable speed pump in parallel. Again, that's if we have multiple heat pumps on a common loop with their own set of pump or pumps. Modulating valve. Modulating valve is modulating valve minimum position and modulating valve itself. Again, if we're dealing with two different forms, again, whether it be open loop or closed loop with either central pumping, or again, another very important thing when it comes to application, if you're going to do a non-pressurized system, we must have a modulating valve unit for closed loop with an external non-pressurized flow system. So we'll go ahead and move this back to the proper setting, which happens to be variable speed pump in single, meaning that it's one pump, one loop. We'll arrow out of this screen now. And the next option here is pump configuration. Again, pump configuration, the factory default is to control the pump via delta T, meaning we're going to measure entering water, leaving water, and the difference between the two is what we're going to control the speed of the pump or the valve position. And the heating delta T is 7 degrees as a default, and the cooling delta T is 10 degrees. You can adjust the heating delta T anywhere from 4 to 12 degrees, and the cooling delta T anywhere from 9 to 20 degrees. Now we have one other option under this screen. If you scroll up to delta T here and then hit the select button, the center button, and then I hit the up or down arrow, we also have an option for fixed speed pump control. So we could give our pump so that it's not going to speed up or down based on delta T. Now we're going to give it a fixed speed for our various stages. Stage 1, Stage 2 for both heating and cooling, so that we could operate the pump in a fixed mode. So that's an option that you also have, maybe a little more dependent upon your application. I'm going to go ahead and move this back to delta T. And go ahead and arrow back out of this menu here. And we'll go back to our main installer settings. And again, a lot of these other menus we've covered in some other videos as far as like accessory configuration, humidity configuration. But one other thing I want to emphasize here is, again, a quick setup. Another very important feature here would be our temperature algorithm, that why we might want to make a change here. We have three options: proportional integral with no downstaging. Well, what would that do for you? Well, again, maybe if we're on, replacing this unit or in a heating dominant area, to give the loop a little more rest and recovery, we might want to choose proportional integral with no downstaging. With no downstaging, once we go into a second stage call in that compressor, we're going to stay in that second stage call until we satisfy the thermostat. Or if we happen to go to auxiliary heat, we're going to stay with the auxiliary heat engaged until we satisfy that thermostat. Whereas just the proportional integral, it's going to look for the most efficient way to run the heat pump, but sometimes that does not correspond to the loop that we have attached to that heat pump. So again, in that heating dominant market, we may want to look at that no downstaging option. And then we've got we'll go back to our installer settings. We got our service mode, again, that we also cover in depth in our actual startup video, where again we go through manual operation, we look at controlled diagnostics, dip switch configuration, as well as fault history. I'm going to go ahead and arrow back out of that. One other thing I want to point out here on the main installer screen is the current revision level of both the DXM2 control board as well as the thermostat. Or if we had a service tool here, it also would show the revision level. So again, if that's ever if you had an issue, that may be something you're going to have to relay to your tech service rep that you might contact if you're having a particular issue. Just very important to know where you can find that on the screen. So let's go ahead now and let's move down to the actual control board. And I want to point out some important features down here next. All right, now we're going to talk about some of the preliminary things we need to make sure are properly set here on our DXM2 communicating control board. And I want to start out with the dip switches and some of their positions. And I'm going to start out here with the small dip switch bank, which we call S3. There's 4 dip switches on there. The one to the far left as you face the board should always be in the on position, or as you see it here in the screen, in the up position. That in the up position is on, down position is off. This is a master-slave dip switch. If I move that to the off position with the thermostat directly connected to this board, we're going to have no communications, and the thermostat's not going to operate. Again, that is used, again, more in our commercial applications where we may have multiple heat pumps tied into one common thermostat. So this should always be in the on position, otherwise your thermostat's not going to work. The other 3 dip switches here are for our hot water generator if your unit happens to have that feature. The number 4 dip switch actually turns the pump on or off. Right now, this one's in the off position. This particular unit does not have a hot water generator, but if we did, after we fully made sure we had flushed out any air that's in that hot water generator circuit going to that tank, we could move that dip switch to the on position to put that pump into service. So again, I'm going to go ahead and move that back to the off position. Next, I want to talk about dip switch bank 1 here. We got 8 dip switches on here. Under most residential applications, these dip switches should always be in the on position. Most of these dip switches have features for different commercial applications. For instance, dip switch number 2, if I was to move that to the off position, this compressor would never come on until a second stage call. That is for, again, some larger pieces of equipment that have 2 compressors in it. Our residential equipment, we do not have any model that has 2 compressors. So that dip switch should always be in the on position. Dip switch number 7 is for a boiler cooling tower application. If that was moved to the off position, once the loop temperature reached 50 degrees, it would go into auxiliary heat, something your customer is not going to be very happy with. So again, all these dip switches should be in the on position for most residential applications. If you think you need to make an adjustment there, be sure to consult the DXM2 IOM and fully understand what they do for you. So now we'll move here from S1 up to S2. S2 dip switches are, again, for our accessories. Again, we can track our compressor or our fan. For instance, if you want to control a humidifier, it might be a very common accessory that we want to tie in with our unit, we would move dip switch 4 and 5 to the off position. I'll go ahead and demonstrate that. Now, again, with our ATC communicating thermostat, it has humidity functions. We can actually control the humidifier through our ATC thermostat. Down here along the bottom, now our N2, NO2 or NC2 are now tracking with the compressor when we get a humidity call. So that might be a common accessory that you might employ on this product. Now let's talk about a couple jumpers here, if you will. The very first one is our JW3. Again, if we're in an area that our loop temperature is going to get below 40 degrees, entering water temperature, we must have antifreeze, otherwise we're going to get LT1 lockouts. And in order to cut this jumper to freeze protect our coaxial heat exchanger, we must have a minimum of 15 degrees freeze protection in that solution. Once we have that, we can cut that jumper with a pair of side cuts. I always recommend have the power off to the board before cutting that jumper so we don't accidentally short something out. Then we can cut that jumper so we do not get a nuisance trip. Now let's take a look over here. This black jumper over here on the right hand side is our AO2 jumper. This jumper is for our option between either a modulating valve or a variable speed pump. It can be in one of two positions. And again, this should be in the correct position from the factory. There's a PWM position or a 10 volt position. The PWM position is for our variable speed pump, the 10 volt position for the valve. If it's in the incorrect position, the pump or the valve will not operate properly. So it must be in the correct position. I'll just demonstrate pulling it off. Again, it's simply, there's 3 pins. It's one of 2 combinations over the 2 pins. Again, this unit happens to have a built-in variable speed pump, so it's going to be in the PWM position. Now, while we're here, we talked earlier about a service tool. And I want to just demonstrate plugging in the service tool. The service tool will have a wire harness with a Molex plug, and the Molex plug simply plugs in here on the P5 connector, right next to where we wired in our ATC thermostat on the P4 connector. Again, only 4 wires. And it's only 4 wires in this pre-made up Molex plugged cable going to our service tool. Once we plug that in, the service tool will take over and allow you to, again, go through several of the menus I just showed on the ATC thermostat. Now, a couple other things inside the box, if you will. I'm going to go ahead and come around here so I can better point them out. With the built-in variable speed pump, it comes with a built-in expansion tank. That expansion tank, there's a couple key things that must be followed in order to put this unit into proper operation that we cover very heavily in our flushing procedures for units with internal pump. Now, there's a bleed port right here. Again, that we must make sure during that flushing procedure that we've bled out any air that's in this tubing. We also have an isolating valve to the expansion tank that once we're in the pressurization process of flushing, we will open that up and then compress the bladder allowing, again, the expansion tank to slightly fill. Now, one other thing, again, I've mentioned earlier, I want to point out again and stress heavily, with the built-in variable speed pump option, this cannot be made a non-pressurized system. Very, very important. Again, if you're going to do a non-pressurized system, you must make sure you order the modulating valve for closed loop, and then have your external non-pressurized flow center. Again, this will conclude our starting procedures for our DXM2 communicating controls.